Here we want to find the limit of 1 plus 1 over x to the 3x as x approaches infinity. So let y be the limit of 1 plus 1 over x to the 3x as x approaches infinity. Take the natural log of both sides. Natural log of the limit of this function is the same as the limit of the natural log of this function, and that's by the limit of composite function theorem. Here we have natural log, so we can move this exponent of 3x and place it in front of the natural log. And now let x run to infinity, then 3 times x will be infinity. 1 over infinity will be 0. Natural log of 1 is 0. So we have the indeterminate form of infinity times 0. We cannot apply L'Hopital's theorem here, since we don't have infinity over infinity or 0 over 0. So what we can do is rewrite this is multiplying by x, which is the same as dividing by 1 over x. Multiplying by x is the same as dividing by 1 over x. And now if we let x run to infinity, then this will be 0, and here we get the natural log of 1, which is 0. And then 1 over x will run to 0 as x approaches infinity. So now we have 0 over 0. Now we can use L'Hopital's rule. And so to use L'Hopital's rule, we would take the derivative of the top and also the derivative of the bottom. Derivative of 1 over x, this is x to the negative 1. Derivative of x to the negative 1 is negative x to the negative 2. Negative 1 times x to the negative 2, which is negative 1 dividing by x squared. Derivative of 3 times the natural log of 1 plus 1 over x would be 3, and then since we have natural log of this expression, the derivative would be 1 over 1 plus 1 over x times the derivative of 1 plus 1 over x. This expression right here, the expression 1 over 1 plus 1 over x, multiply the top by x, multiply the bottom by x. 1 times x will be x, and then multiply this expression by x, we get x plus 1. And then we have a 3 here. So multiply this quotient right here. Multiply the top and the bottom by x, then we get x over x plus 1. And then we have multiplying by 3. The derivative of 1 plus 1 over x, derivative of 1 is 0, derivative of 1 over x is negative 1 over x squared. So we get negative 1 over x squared. X dividing by x squared, then we get x down here. So here we get 3 times negative 1, which is negative 3, and then down here we get x times x plus 1. And so the limit of this now becomes the limit of this right here, because the derivative of this is negative 3 over x times x plus 1. And derivative of 1 over x is negative 1 over x squared. And now this is the same as negative 3 over x times x plus 1 times the reciprocal of this, which is negative x squared over 1. Negative times negative is positive. X squared dividing by x is x. So that's how we get 3x on the top, and in the bottom here we just get x plus 1. And now if we we let x run to infinity, the top will go to infinity, the bottom will go to infinity. So we get infinity over infinity. So we can apply L'Hopital's rule again. So applying L'Hopital's rule again, we take the derivative of 3x, which is 3, and then the derivative of x plus 1 is just 1. So that's one way of doing it, it's just 1. And so we get 3 over 1, which is 3. And so we have the natural log of y is equal to 3. Y is what we're looking for. And so to go from natural log of y to y, we use the definition of exponential function. And this definition says that the natural log of y is equal to x if and only if y is equal to e to the x. So here we have the natural log of y is equal to 3. This is equivalent to saying y is equal to e to the third. And again, recall that we call this limit expression right here, we call this y. But y is equal to e to the third. So this is the answer, e to the third.